Hello friends, so this is CSIR NET previous year's questions answer solved question paper based on Lagrangian and Hamiltonian. So this is part 3. So in part 1 and part 2 we have already solved from question 2011 CSIR NET to 2013 in part 1, and in part 2 we have solved from 14 to from 16. So here we are going to solve from 17 to 19. Links of part 1 and 2 will be given in the description box. So if you haven't watched those two, please go through. So our first question is from NET June 2017. So here Hamiltonian of the system described by the generalized coordinate x and generalized momentum p is given by this equation. This is the Hamiltonian, and where alpha, beta and gamma alpha, beta and omega are constant, and we need to find a corresponding Lagrangian. So what to do first of all? So let it be minimized. Okay, now here you see. So let me write the Hamiltonian first. Given Hamiltonian is H is equal to alpha x square p plus p square by 2 into 1 plus 2 beta x. This is the Hamiltonian, and here half omega square x square. So here you can consider this part is as potential Vx, and here you see as this is p square, but this is not p square, only p, so that's why we cannot compare with this term, and that p square by twice m. If we can compare with this term, then it will be easy to get the Lagrangian, but now here we cannot apply the shortcut here. So now here we are going to use the relation between Hamiltonian and Lagrangian. So what was the relation, if you remember? So the relation was, L is equal to summation I pi qi dot minus s, something like that. Here momentum is p and position is represented by x here, so we can write px minus s. So L is equal to, we can write this. So now let us find p and x dot from this relation. So we know x dot is given by Hamiltonian equation of motion. By Hamilton's equation of motion, we get x dot is equal to del h by del p. So if you differentiate this Hamiltonian with respect to p, then what will happen? You will get alpha x square plus p by 1 plus twice beta x. So we get this. Now from here, if you simplify this equation, you will get p is equal to, if you simplify this relation, x is equal to x dot is equal to this one, and from here if you find p, then what you will get? You will get x dot minus alpha x square and into 1 plus 2 beta x, isn't it? This term is brought to this left hand side, then cross multiplication and further simplification, we have got this value of p, isn't it? So now you see what we can do from here. So now replace this value of p, replace this p and p square by this value of p in the Lagrangian. Then what we will get? So let me scroll down the piece. So if you put the value of p there, then you will get, not here, here in this relation. If you replace the value of p here, then what you will get? You're gonna have L is equal to x dot minus alpha x square into 1 minus twice beta x into x dot minus h. And now let us put the value of h. This is the value of h. This is the Hamiltonian h, isn't it? So let us use this here. Then we can write here alpha x square p plus, sorry, not plus, there because of this negative sign, this sign will be changed, minus p square by twice 1 plus twice beta x minus half omega square x square. So we have got this. So now let's simplify. If you here, it should be plus, okay, this should be positive. Now replace this p and this p by this value of p. Here you can see. So we are going to replace these two p's by this value of p here. Then we will get x dot minus alpha x square 1 plus twice beta x x dot minus alpha x square into x dot minus alpha x square into 1 plus twice beta x, then minus x dot minus alpha x square whole square 1 plus twice beta x whole square divided by 2 into 1 plus twice beta x minus half omega square x square. That's what we have got. So this term we cancel with this square. Then you can see here these two terms and these two terms are common. After taking common, we will left out these two terms. So that's why we will get this x dot minus alpha x square 1 plus twice beta x, and remaining terms are these two. So after taking common, x dot minus alpha x square. So we have got this, and then we have got minus. From here we will get minus x dot minus alpha x square whole square into 1 plus twice beta x divided by 2 minus half omega square x square. So here you see these two are same terms. So instead of writing twice, you have to you can write here square, and let me remove this. So we can write this way, isn't it? So hope you have understood this. So now let me scroll down the page. Now from here we can take 2 LCM here. So after taking 2 LCM, what we will get, 2 into x dot minus alpha x square whole square 1 plus twice beta x minus x dot minus alpha x square whole square into 1 plus twice beta x. So here minus 1 by 2 omega square x square. So here you see you can subtract these two terms, then you will get again x dot minus alpha x square into whole square 1 plus twice beta x by 2 minus half omega square x square. That is what we have got. So now which option is correct according to this result? So according to this result, which option is correct? So let's check the question. So option A. So here is the half, that means divided by 2. You can consider that. Then this is the potential. So our correct option is A. So that's what we have got. This is the answer, Lagrangian L. Okay. So now let's move on to next question. So our next question is here, June 2017 CSIR NET. Here the Lagrangian of a relativistic particle is given. This L is equal to this one, where x dot represents dx by dt. So that's what we know. And trajectories of corresponding Hamiltonian. We need to find trajectory. It may be ellipse or hyperbola. Let's see what is it. So first let us write the Lagrangian. So given Lagrangian is L is equal to minus m root over 1 minus x dot square. This is the Lagrangian here. Potential is not given here in this case. So we know Hamiltonian that we have already got in the last in the previous problem. Here you see that we have solved already, that x dot p minus L. So p is equal to we know del L by del x dot. Remember this. If you don't know, then remember this. P is equal to del L by del x dot. That is also an important relation. So if you find the derivative of L with respect to x dot, then what you're gonna have, minus m by 2 1 minus x dot square whole to the power minus half minus 2x dot. You're gonna have this. Okay, so squaring both sides, if you square, p square will be m square by 4, then it's gonna be minus x dot square whole to the power minus 1, and here it will be 4x dot square. You're gonna have this, then 4 cancel here. So, and this implies, if you simplify this, then you will get p square is equal to x dot square m square plus p square. So you will get this after simplification. I have not shown all the simplification steps here. So then x dot square will be, and x dot square will be p square by m square plus p square, and hence x dot will be root over you can write p here directly, and root over m square plus p square. You will get this. So let us use these values here in this Hamiltonian. Then what you will get? Now you see what we're gonna have here. If you replace this x by this value of x, then you will get, so let me scroll down the page. Okay, then you will get h is equal to p by root over m square plus p square, and there is one more p here. So instead of writing this p here, so let's multiply with this, then you will get this expression. So minus L we know the Lagrangian here, minus m root over 1 minus x dot square, that is. So here also you can replace the x dot. If you replace this x dot by x dot square by this value, then what you will get? So if you do so, then you will get h is equal to p square by root over m square plus p square, then plus m 1 minus p square by m square plus p square. And if you simplify this term, then it gives m square plus p square minus p square by m square plus p square under root. This is under root, so here pp will be cancelled. Finally you have good this m square by m square plus p square under root. So then this can be written as m by root over m square plus p square, isn't it? So then there is also m. If you multiply this one with this, then what you will get? Then this term will be, this part will be, we can write directly. Let me clear this portion. So we can write here m square. So we can write here plus m square by root over m square plus p square. We can write this, isn't it? So hope you have understood this. Now here what we can do, we can take LCM. So if you take LCM, let me clean this part. So from here we will get root over m square plus p square LCM, and here p square plus m square. So dividing this term by this, definitely you will get h is equal to root over m square plus p square. Yes. So you get this. So here you see, here potential was not given. Here we know that f is equal to minus dv by dx, isn't it? So here dv will be dv will be minus f dx. So integrating both sides. But here you see one more thing. Here force applied is constant. So where it is mentioned, maybe somewhere it must be constant force, isn't it? Okay, in the question. So that's why we are not not integrating the term f here. So f v will be equal to minus f of x. So we have to write here minus f of x. So now here you see, we know Hamiltonian is kinetic energy plus potential energy. So that means it gives us total energy. So let us replace this h by E. So what we can do here, we can write E is equal to root over, and one more thing, let us bring this minus f of x to this side, then it will be plus f of x. That's going to be root over m square plus p square. So this is what we have got. Now what we are going to do, squaring both sides. If you square both sides, e plus f of x, sorry, not f of x, f into x here. So whole square, that's going to be m square plus p square. So now this implies here e plus f of x whole square minus let us bring the p square term on this side, p square. So here you will get m square, and dividing both sides by m square, then you will get e plus fx by m whole square minus p by m whole square is equal to 1. And this is equation of hyperbola. This is equation of hyperbola. If you compare with this equation, x square by a square plus minus y square by b square is equal to 1. So our correct option will be, so what will be the correct option here? Option C, hyperbola. Okay, so this is our next question from NET 2018 June. So here Hamiltonian in a one-dimensional system is given by this, and here m and n are positive constants. Corresponding Euler Lagrange equation, we need to find that. So let me make it smaller, minimize it. So here let me write the given Hamiltonian, that is h is equal to x p square by twice m plus half kx. Now here this term can be considered as Vx, isn't it, potential. So here you see, as we have p square term here only, so we can compare with this p square by twice m with this term, that is equal to x by x p square by twice m. So here p square gone and 2 gone, so we will get m is equal to small m by x. So we know L is equal to t minus v. So t is considered to be here half mv square. Here this v represents velocity, and here it is potential minus v of x. So let us replace this m by small m by x. So we're gonna have 2 m by x, and here v square will be x dot square, velocity, and this potential is nothing but half kx. Hope you have understood this. This is the potential. So we have got the Lagrangian here. Now what is the Euler Lagrange equation? So that was let me use the black color. That was del L by del x dot its time derivative d by dt, and minus del L by del x is equal to 0. So let us find first del L by del x dot. If you find that here this is the only x dot term this is the term only contains x dot. So here you will get m x m by x and x dot, this one you will get. And del L by del x, if you differentiate this with respect to x, then you will get minus m x dot square by twice x square. You're gonna have this. Okay, so here you see, now if you differentiate this term, then you will get only half k only. So now let us put these two values in this equation. D by dt of m x, here it is x dot minus m x dot square by twice x square minus half k is equal to 0. So now let us simplify this. So if you differentiate this with respect to time t, then you will get x m x double dot minus m x dot square, because here we are using u by v rule, okay, quotient rule of derivative, by x square plus, and here we are getting half m x dot square by twice x square plus k x half k, so, or you can write k by 2 equal to 0. So if you multiply both sides by this term 2x square, if you multiply both sides by 2x square term, so then what you will get? So you will get twice x m x double dot minus m x dot square plus k x square is equal to 0. And which option is correct? Now let me check. So this is our answer. So I think here option C, this is correct. So this is our equation that we needed to find. So hope you have understood this. Now let's move on to next question. So our next question, December 2018 CSIR NET. The motion of a particle in one dimension is described by the Lagrangian. This is the Lagrangian. Then value of action along classical path, we need to find the value of action. So x is equal to 0 when t is 0, and x is x naught when t is t naught. So here let me write the Lagrangian first. So L is equal to half, so dx by dt whole square minus x square. So this is the Lagrangian, so which we can express in this way. So dx by dt means x dot, so it is square minus x square. So now you see, if you know the equation, Euler-Lagrange equation that we have already used recently, we have used this was the equation, Euler-Lagrange equation is equal to 0. So now if you find this one, and if you put here, then you are going to have d by dt of then x dot plus x is equal to 0, and which implies x double dot, this is x double dot, isn't it? X is equal to 0. That's what we have got. Now here you see, so we need to find a value of action. So action is, that is given by t1 to t2. That means here t1 is first initial is 0, then we have got t naught. We have to integrate this L with respect to t, but here we have got only x and x double dot, not t. Okay, so in that case what we can do, so here you see, this is a differential equation, and the solution of such differential equation is given by x of t is equal to a sin t plus b cos t. Okay, So this is the solution. Now here you see, if you we know that x is equal to 0 when t is equal to 0. T is equal to 0. So let me write. Sorry. When t is equal to 0. So if you put these values, then what you will get? So then you will get this is equal to 0, then a sine 0, b cos 0, and here we know sine 0 is 0, so we will get simply b is equal to 0. So value of b is 0, so this term will be 0. So again, if this is 0, we will get remember one more thing, so that t naught, when time is t naught, then x was x naught, isn't it? So that's why in that case we can write using these conditions, x naught is equal to, so from here, from this relation, x naught will be equal to a sine t naught, as these terms become 0 after putting this value of b, so we get this. So here the value of a will be x naught by sine t naught, isn't it? Now instead of a, we are going to use this value. So then from this relation, what we are going to have, we're going to have x t is equal to x naught sine t by sine t naught. We have got this. Now let us find the value of action. So that is s is equal to 0 to t naught L dt, that's going to be equal to, so one more thing, we have got this value, then what will be the what will be the Lagrangian then? So Lagrangian, we have got L is equal to half x dot square minus x square. We have got this, isn't it? So let us put the value of x dot and x square here. So from here, what will be x dot? We know. So after putting this value here, x dot and x, there is squares, x dot square and x square. So what we gonna have? X naught square by sine square t naught, sine square t naught cos square t minus x naught square by sine square t naught by sine square t. So we have got this. Okay. So because if you differentiate it with respect to time, you will get x naught minus x naught cos minus x naught cos t by this sine t naught. Okay, sine t naught. So after squaring, we have got this negative will be positive here after squaring. So because here we have x dot square, in this case you can see. So we have got this. Now if you simplify this whole thing, then you will get a simple expression, L is equal to half x naught square by sine square t naught cos 2t. Okay, so I hope you can simplify yourself this equation. Just take this part common and use cos square t minus sine square t, that is equal to cos 2t. Okay, that's it. So now let us use this value of L here. So if you use this, then what you will get, 0 to t naught, that half will be outside the integral. So then x naught square by sine square t naught cos 2t. So and after integration, so this part will be constant here, x naught sine square t naught, it is constant term here. So half we can write x naught square sine square t naught outside, integration 0 to t naught then cos twice t. Integration of cos twice t will be sine twice t by 2, isn't it? So that's why we have got x naught square by 2 sine square t naught, and it is sine 2t by 2, and our limit is 0 to t naught. If you put the limits before that, okay, if you put the limits, you will get this result: x naught square 2 sine square t naught, and on putting 0, this term becomes 0, so we can put t naught only. So if you put t naught, then 2 sine, using the identity sine twice t, that's sine 2t cos t. So here we are putting t naught also, so that's why it will be 2 sine t naught cos t naught by 2. So we have got this. So this 2 gone, and sine square and sine t naught, this is gone. So we have got x naught square by 2 cos t naught by sine t naught, sine t naught, and that gives x naught square by 2 into cos by sine is cot t naught. So this is our answer. So which option will be correct? Let me check. So here, so this is option C. Option C is correct. So hope you have understood this. Now let's move on to next question. So this question is from CSIR NET 2019 December. So here, this is the Lagrangian, which is the function of x, y, and x dot y dot in 2 dimensions. So we need to find that which option will satisfy the equation of motion, that means Euler Lagrange equation in this case. So first of all, here you see, here Lagrangian is function of x and y, x dot y dot, we know that only, we don't know the Lagrangian, so we have to solve it from the option. So here you see, now we know the Lagrangian, if it is function of x, x dot and t, then we used to write the equation d by dt of del L by del x dot del L by del x is equal to 0. Suppose we have x dot, x double dot and t, then what will be the equation of motion? In that case, it is second derivative here, del L by del x dot minus then d by dt of del L by del x dot, then plus del L by del x. So here you see, on this left hand side, we will put one by one options from this, then which one will satisfy this equation, that gonna be the answer. Okay, so first let us check the first option. Option A is given here, x dot minus y dot. This is the first option. If you use this, then what you will get? So second order derivative of this one, if you differentiate with respect to x double dot, then what you will get here? You will get x only, then remaining this part will be 0, then minus d by dt. If you differentiate with respect to x dot, this term, this doesn't contain x dot, so it will be 0, then plus, if you differentiate with respect to x, then you will get only x dot. So here it is not equal to 0, so let me check, is that equal to 0 or not? This is x double dot, this is 0, and this is plus x double dot, so this become twice x double dot, so it is not equal to 0. So first option is not correct. So let me check the second option, B, x y double dot minus y x double dot. So in that case, if you find del L by del x double dot, then you will get here minus y, second order derivative of minus y, then minus, if you find this del L by del x dot, then you can have 0 again. Then if you find del L by del x, then you will get y double dot here. So if you check, this is minus y double dot, 0 is 0, and then y double dot. If you cancel this two, then you get 0. This is the right hand side, so it satisfies this equation. That's why option B is correct. So correct option is B. So hope you have understood this. So if you like the video, please hit the thumbs up button and help me to grow my channel. Please subscribe the channel if you are new to my channel.